All right, let's dive into a really fascinating race that's happening right now in the world of AI. And it's not about making AI bigger and bigger in some far-off data center. Nope, it's about shrinking it, making it small enough to live right here, in the palm of your hand.
I mean, just stop and think about that for a second. What if the kind of powerful AI that runs tools like ChatGPT could work entirely on your phone? No Wi-Fi needed, no cell service, nothing. Just you and a truly personal AI. It sounds a little like science fiction, right? But it's a very real challenge that some of the smartest people on the planet are trying to crack.
So why does this even matter? Well, right now, almost all the AI you use runs in the cloud. You type something, it gets beamed to a giant server farm, gets processed, and then the answer gets sent back. That creates two huge problems. Your private data is leaving your device, and there's always that annoying lag. On-device AI, well, it flips the script completely. Your data stays with you. And because there's no round trip to a server, the responses could be instant.
Okay, so if on-device AI is so obviously better, what's the holdup? Why don't we all have it already? Well, that brings us right to the heart of our story today, a massive, tricky engineering puzzle known as the Edge Computing Challenge. Edge computing, that's the official name for this whole idea. It literally means pushing all that computing power away from the centralized cloud and out to the edges of the network. You know, to your phone, your laptop, maybe even a tiny smart sensor. It's a fundamental shift in how we think about where the thinking happens.
But, and this is a big but, trying to run these gigantic AI models on our little devices is incredibly hard. First off, battery life. These models are absolute energy hogs. Second, the hardware is a total Wild West. Every phone is different, every laptop is different. It's not like the uniform servers in a data center. But the biggest wall they're hitting, the one we're really going to focus on, is the absolutely insane demand these AIs put on a device's memory.
To really wrap your head around this, think about it like this. A pretty standard AI model like Llama 7B takes up about 13 gigabytes of space. Now, a really nice high-end phone might have 16 gigs of RAM, total. And that RAM has to run the entire operating system, all your other apps, everything. So yeah, it's literally like trying to cram a full-grown elephant into a tiny Mini Cooper. It's a serious squeeze.
So how in the world do you even start to tackle a problem this massive? Well, you start by figuring out how to measure it properly. You can't fix what you can't measure, right? And to do that, some researchers came up with a pretty brilliant new tool. It's called ELIB. Think of it as a standardized test track for AI models running on all these different edge devices. It's this universal system that lets researchers take any model, tweak it, automatically shrink it down, run it on a device, and then analyze a whole bunch of performance stats in a totally fair, apples-to-apples way. And as part of ELIB, they came up with a new way to keep score. It's called Model Bandwidth Utilization, or MBU. And this is a really cool idea because it totally shifts our focus. It suggests that the real bottleneck for AI on your phone isn't the processing chip, it's memory. MBU basically measures how efficiently an AI is using the memory highway in your device. A perfect score is 100%, meaning you're not wasting any of that precious bandwidth. So we've got the test track, we've got the new scoreboard. It was time to start the race. The researchers brought in a really diverse lineup of devices to see how they'd actually stack up under this new, super rigorous system.
And here are our contenders, covering the whole spectrum of what you might call an edge device. We have a little low-power NanoPi, which you'd find in a smart home gadget. We have a pretty standard Xiaomi smartphone. And then we have the powerhouse, a MacBook Air. And just look at the difference in their memory bandwidth. The Mac has almost double the bandwidth of the phone. That's going to be important later.
Now, they didn't just test one version of the AI. They used a really clever trick called quantization to create different weight classes of the Llama model. Basically, quantization is a way to shrink the model by making its internal numbers a little less precise. And look at the results. They took that massive 13 gigabyte model and squished it all the way down to a much more manageable 3.5 gigs.
Okay, now this is where things get really juicy. Because when you test things this carefully, you start to uncover some stuff that is genuinely surprising and honestly a little weird. So the first big mystery they wanted to solve was pretty simple. What is the single biggest thing that makes these models run fast on a device? Is it the raw speed of the processor? The number of cores? What's the secret sauce?
And the answer couldn't have been clearer. It's all about memory bandwidth. The real bottleneck, the thing that slows everything down, isn't how fast the chip can do math. It's how fast it can pull the AI model's information out of RAM. This is exactly why that MBU metric we talked about is such a game changer. High MBU equals high speed.
And you can really see this play out when you look at the raw performance. I mean, the gap is just staggering. Throughput is basically how many words the AI can generate per second. And the MacBook, with its superior memory bandwidth, just blows the other devices out of the water. It's cranking out almost 20 tokens a second, while the phone can barely manage 6. But speed wasn't the only thing they were measuring. They were also hunting for strange, unpredictable behaviors, and oh boy, did they find some. What they found shows just how incredibly complex this whole challenge really is.
Now get this, because this is kind of wild. On the CPUs they tested, trying to use more processing threads actually made the AI run slower. You'd think, logically, that throwing more cores at a problem would speed it up, but no. Because of some really deep, complicated optimization issues, using just 4 threads was often way more efficient than using all 8.
But here is the absolute biggest shocker of the whole study. Accuracy. Some of the devices might have been fast, but their answers were a total disaster. We measure this with something called a perplexity score. Just know that lower is better. The Mac's GPU was just as accurate as its main processor, but the other GPUs? They were nearly 10 times worse. They were producing answers that were basically gibberish. It's a huge red flag, probably caused by software glitches, and it proves that speed means nothing if the answer is wrong.
So what does all of this super technical research actually mean for us, for the future? Well, it means we are finally building the tools we need to create the next generation of AI, one that's truly personal, completely private, and incredibly powerful.
So, if we boil it all down, this whole thing leaves us with 3 huge lessons. First, if you want fast AI on your phone, memory bandwidth is king. Forget everything else. Second, shrinking models is absolutely necessary, but it's this delicate dance you have to do to avoid destroying its accuracy. And finally, none of this works, not a single bit of it, unless the software and the hardware are perfectly in sync.
Look, I know this stuff can seem really deep in the weeds, and it is, but this is exactly the kind of foundational, nitty-gritty research that paves the way for the technology we're all going to be using in just a few years. They're basically writing the rule book for this whole new era of personal AI.
And that kind of brings us to the final thought. The race is on, and it's moving incredibly fast. So the question I want to leave you with is this. When they finally crack it, when you have a powerful AI that lives only in your pocket, one that's truly and completely yours, what are you going to do with it? Thanks for tuning in.